So I'm Kevin Collins. I'm a business analyst and solutions architect for TriStar. I've been within the industry for over 25 years, and I've done assessment, developing, maintaining all different types of data management solutions, and developed and enhanced many different types of engineering solutions, and even deployed global PLM solutions, most predominantly for Whirlpool Corporation, which was, as stated, a global corporation with over 100,000 employees worldwide. I'm trained in Lean, Kaizen, and CM2, and those are some of the key tenets that we'll be talking about and kind of lean on today. So that's kind of the building blocks for a lot of what we're going to present today. As for TriStar, I've been with TriStar for a little over a year now. We're headquartered in Phoenix, Arizona, and we're PTC's largest value-add reseller for the PTC solutions. We also execute and we develop and provide over 400 different migrations and implementations for thousands of customers across North America. Sorry, I hit the wrong. Some of the things we do, of course, is full PLM with multicad, BOM, do bidirectional communications with ERP systems. We cover all major CAD systems, ERP into PLM, and we do some software development. There's over 400 different extensions, over 500 different extensions that needs to be updated, and apps, Windchill that we provide. These are add-ons that work along with Windchill to help do some of the automation and metrics reporting that we'll be talking about a little bit. So the first thing that we like to talk about is, what is PLM? So unfortunately, there's probably more misinformation out about what PLM is than there is that you could get your hands on telling you really what PLM is really all about. There's been a lot of different spins and different ideas that have been put out there that don't necessarily align with what the true core PLM definition is. So we're going to spend a few minutes talking about what PLM, and the best way to do that is to put away some of the misnomers that are out there, some of the more predominant ones. And first and foremost, PLM is not hardware or software. It's not, Windchill is a great piece of software, one of the most capable tools out there, but it in itself is not PLM. It is PLM capable. So, and this is a common thread that you'll see us talk about over and over again. Installing software isn't going to provide you with PLM. Okay, now software is necessary. We don't want to belittle it. Could you do PLM manually? Absolutely. Is it worth trying to do that? Absolutely not. I mean, of course, software is going to make any tool more robust, and it's not, Windchill by itself isn't going to give you everything you need. Typically, you're going to need some type of ERP system. So as far as ordering parts, inventory management, backflushing, and some resource management, you typically are going to need some type of ERP system. So we typically talk about Windchill and ERP working together to provide PLM. There's other systems that may be on the periphery, but for the most part, those are the two big players. One thing about software, while we're on this, is just like Windchill, all your different softwares are highly configurable. They're trying to play to all the customers, right? So if I'm making a car, then I'm going to need a lot of different configurations and capabilities that I'm not going to need if I'm making an ironing board. The complexity is just not the same. There's a lot of things about PLM that just aren't the same. Lifecycle, for example, may be one of them, and we'll talk about that in a little bit as well. So configuration or configurability is something that comes up a lot, and people will say, well, when you will let me configure it to do this? And when we're looking at your business or looking at a business and looking at what makes sense for your industry, whether you be built to order, built to stock, or engineered to order, configured to order, depending on your profile, that configuration may not be appropriate for you. So when we start talking about configuration, it's just important to understand that the configurability of a software like Windchill, don't mistake that for validation for that process for you specifically. So just because Windchill will let you do something, or just because it's capable, doesn't mean that's the best approach for you. And that's where there's a lot of people that can slip into that, and we've seen that before. So that's one thing to remember when we're talking about software or Windchill specifically. The other big misnomer is that it's a relatively new concept. Probably within the last decade, there's been a lot of movement and desire for people to try to move toward PLM. And it was actually the basics were pretty much laid back in the mid 80s, I believe it was, with AMC and Rockwell. They were the two big ones. AMC, of course, being the automotive manufacturer, and Rockwell producing the B-1B bomber. They both laid the foundational steps for PLM. Like I said, back in, I think it was the mid 80s. And AMC, what they were really doing is they were laying those foundations for what is truly PDM, and that's kind of the predecessor. And again, we'll talk more about this. And that's really the predecessor for what builds up for PLM. And so when Chrysler bought AMC and saw what they had done with their PDM results, they kind of expanded it. They said, well, if you can do this really within the design environment, you can really do some great things if you apply it across the entire enterprise. And that includes your service organization, your marketing and sales and procurement. And so they really tried to couple and expand what PDM was, and that was pretty much the first deployment of PLM. It was the first generation of the Jeep Grand Cherokee, or there may have been a precursor to that even model line, but it was pretty much the Gen 1 of that platform. So you can see that if PLM is built on PDM, it's not really an alternate concept, it's a more advanced concept. So a lot of people will say, well, I'm going to do PLM instead of, and that's just not, it's just not so. You have to, if you're going to do PLM, that means you're going to be doing very good PDM. And conversely, PDM was based on CM2, which we'll talk a little bit more about here in a moment. CM2 being configuration management 2, which even goes back further into the defense industry. And so if you're going to be doing these things, then it comes back to doing these robust data and design management techniques. The reason we talk about this is because it is so very critical to understand the CM2 connection to PLM. The rules that are there for CM2 come into play for PLM more so than you could probably imagine. And so as far as your data and your processes and things like that, how that starts to formulate and how that starts to build up, if that's not done with the CM2 philosophy in mind, and again, we'll talk a bit more about this, then you're probably going to fail at your PLM attempts. I've personally seen that happen, and company I was working for kind of jumped into the middle of PLM and didn't really go back and look at some of their legacy data and processes. They were thinking, we're already doing that, we're going to move forward from there. And they spent about 2 years spinning their wheels. And once we got the understanding that CM2, good design management and data management practices were needed, that's when things really took off. We went back and fixed that, and it moved along a lot faster and a lot more effective after that. And because of the expansion of PLM across the enterprise, another big misnomer is that PLM is driven or owned by the design engineering group. That kind of follows the design engineering group around quite a bit because they have the technology, they have the processes, they have the documentation. And so anything that requires discipline just kind of gets coupled to what engineering is doing. In this particular case, and I talk a lot about this with my customers, it's almost like we're encouraging you to build silos. And that's not really the case. But what we're trying to do is get people to own their piece of the business and then participate accordingly. And so we want to make sure that procurement is managing the procurement items that they are responsible for, but they're doing that within the PLM environment. So they're in a shared space. You want to make sure that service is doing the service type activity, but they're doing that within the PLM space. So we're just trying to put accountability for who owns what and making sure that the appropriate people are doing the appropriate work. But at the end of the day, it's an enterprise effort. It is not a design engineering effort. And so because of that, it's imperative, and I should underscore that word, it is truly, truly imperative that an educated and focused steering committee is making sure that all the participants of a PLM effort are trained up, informed, and aligned on their transformational efforts. So once you have your PLM roadmap, once you know what that looks like, every piece of the enterprise needs to be participating in moving toward that, down that roadmap and understanding the cause and effect. And again, cause and effect is something that we'll talk about here in a bit. So that's a lot about, oh, and there's one more, I forgot about this one. It's not simple, easy, or fast. A lot of people say, well, I bought Windchill, just put my stuff in there, we're doing PLM. Or I bought it could be any product. We're not just picking on Windchill. It could be any PLM capable solution. I bought it, I put some data in there, we're PLM, we're done. It's not that simple. Typically it's going to require you to really look at your data and your processes and put everything in there the right way. Just simply saying I've automated it with a computer now is a little bit short-sighted. That's like saying just because I have my building plans on the computer, my building is done right. If you didn't use the right materials, i.e. your data, or you didn't use the right instructions, your workflows or your processes, your results are probably going to be severely flawed. So the computer is just a tool, just like anything else, right? So the reality is there will be some challenges, but they can all be overcome. So we've talked a lot about what it's not. So what is PLM? And this is pretty much the definition that most echoes what we would say is appropriate. And the main thing to take away from this, and I'm not going to read it, it's up on the screen, and I know some of you are reading as I'm talking, and I'm not going to read slides to you because that's just boring and a waste of time. But the main thing to take out of this is that PLM is a process, and it really is about taking care of a product line from concept to disposal. Those are basic to endpoints. It's universal for almost everybody, right? You have an idea or a concept for something, and you've got, at some point, somebody's going to discard of that product, right? So that's where the life cycles came in. And some life cycles will be applicable to almost everybody. Some of them won't. For example, I'll go back to my car example. If I'm providing a car, if that's my industry, you can bet that I'm going to have some service life cycle that I've got to consider. If I'm doing I'll go back to my ironing board. If I'm doing ironing boards, I'm probably not going to have an ironing board technician come out and do service. So that may not be a life cycle that the ironing board industry would consume or would leverage. And it very well may be. I'm not in that industry, but my point is, once we understand your industry, your products, how your products are managed, both internally as parts came in to your facilities, and externally after they're sold, that's what dictates what your life cycles are. And these life cycles are critical to a lot of the control, because each one designates activity that can and can't happen. For example, if I'm down here in concept or even development, I probably shouldn't have a lot of purchasing activity going on right then. There's probably going to be, coming out of development, and this little line here would represent maybe the release state that we talk about so much. Once something is released, then it could be procured and brought into the plant for assembly, and so on and so forth. So we want to make sure that those life cycles have very very good controls around them. And the reason these life cycles are important is because, like I said, that's where you get into managing your data and your processes. And we want to make sure that we connect that data and process as much as possible. So a lot of people may say, well, we've already got that because we've got our window, we got Windchill, we got our Windows file system, we got ERP, we may have some other softwares that are out here. And this is a lot of very similar to what we see a lot of times with some customers. But the problem with this particular setup is what you're seeing here is probably some manual processes. I've got to move data from here to here, or I'm creating duplicate data. I'm making copies from one system to another. I'm putting a PDF. These are some of the code words or code phrases that we listen for that may make our ears perk up and realize there may be something there that we need to dig a little deeper. When we hear we've got to publish a PDF over here, or we've got to do this, we got to send a copy over here, things like that. That's some good code words. What we want to see is some integrated data through our integrated processes, and that's working. The processes is what's moving that data from system to system to system. Now, you may have data that resides in different systems, but we want that to be done in a very automated way. And we would still say, try to leverage a single point of data as much as possible. So we've talked about what PLM is, we've talked about what PLM is not, and we've made a very hard connection to CM, or configuration management. And so we'll just kind of jump right into this with the definition. And again, I'm not going to read this to you. I'll kind of let you guys take in this definition. But the main thing I want to point out here is that it looks very similar to the PLM definition. And so, main thing being they're both processes. And the other thing that's pretty similar is throughout its life and the entire life cycle, Now, one of the key differences probably is CM, or configuration management, typically is focused on product definition and physical functional attributes. So it's a very, configuration management typically is very design driven. And as we talked about before, we kind of kept expanding that. You know, CM is really about design. PDM is more product data, and then PLM is the product data and the processes all around it. So that's one of the big differences. And the other thing is CM is very, very rigid about establishing and maintaining consistency. And that's where it becomes very critical to make sure that that consistency is driven, because if your design starts to fall apart, then and everything's attached to that design, then all your periphery or all your attached type information is at risk as well. So these aren't the four magic rules, I'll go ahead and say, but these are probably the four biggest issues that we see people struggle with. And we're going to go through each one of them in detail here just real quickly. And these are some foundational elements around CM2. Single source of truth, documentation, primary intent, being part-centric. And this, I know this sounds a little crazy to say it this way, but being part-centric by being documentation focused. And I've got some illustrations that hopefully will make a little more sense. And then of course, lean closed loop processes. That is a huge one. So we'll just kind of jump into this and kind of talk about those a little bit and why they are so critical. But first of all, just a quick illustration about building a PLM solution, you know, pretty much from the ground up. And this is pretty much everybody's current condition, or most people's current condition. They've got some CAD management, and they typically may have some manual change management. And I say manual, even if it's in a computer, they're doing a lot of routing and you know, gathering around meetings, things like that. But for the most part, it's still very manual as far as collecting information and things like that. So as we start taking some of the things that we're talking about, and we say, okay, first thing we want to do is we want to understand what our CM2 principles are. We're going to start building on that. So CM2 pretty much becomes our foundation. And then from there, you can say, we'll go back to those, we'll just use those four basic issues that we were just talking about. And so we establish a single source of truth for all of our data and documentation, so that we have no redundancy within our data system. Ensure that we adhere to a primary intent. And we'll talk about why that's so important here in just a moment. But we want to make sure that if it's a test procedure, that's all it talks about, is being the test procedure, right? And being, again, part-centric, having something that we focus on anytime we're talking about an item or an artifact within our enterprise. So this is on the data side. On the process side, we want to make sure that we take our manual change process and we review it in a truly lean and Kaizen events or value stream mapping, things like that, and try to automate it as much as possible. And the nice thing about automation, in order for you to do that, you have to establish standards. And once you have standards established, that really drives a lot of consistency throughout your data. So there's already an impact being driven from the process side back over here to the data side. Review your processes to ensure they are dedicated and governed. Dedicated meaning we're managing the appropriate data types with the appropriate workflow. Again, we'll talk more about that here in just a moment, but we want to make sure that they are dedicated and that they are closed loop, meaning my process can't start at step 14. It's got to start at 1 and it ends at 20. And once it ends at 20, it can start back at 1. We're within you're not to that end point yet, you can't start another process because that's going to create a conflict in data. So that's what we're talking about, closed loop. Once the process is started, it continues until it ends. Okay. Oh, and then the dedicated workflow. More specifically, making sure that you're not trying to use one workflow, and I'll just be very to the point, we're not using change notice to try to govern all of our documentation. There's typically a lot of overhead in change notice, and that's not necessarily needed for quite every data type. We've got some more detailed presentations around specifically that we could jump into later if we have time. And so lastly, we want to make sure that we develop meaningful metrics and allow the system to govern. And what we mean by that is, for example, how many CMs did I write this past month? That in itself is not a great metric. I mean, it's maybe a good data point, but not necessarily a metric. I can't say that I'm doing a good job or a bad job just by saying I have a lot of or a certain number of change notices that I processed this month. I could spin that two different ways, or a bunch of different ways actually. A lot of change notices could mean I've got a lot of issues that I'm reacting to. A lot of change notices means my people are very reactive and responsible for doing the work that's coming their way. So there's good or bad depending on how you want to spin it, but just the number of change notices itself isn't really a metric. It's just a piece of data. So making sure that you have really good metrics around what you're trying to gather. Why am I doing change notices? So how many change notices did I have because of quality issues? How many change notices did I have because of new product ideas or new product capabilities? That's where you start to get into more meaningful metrics. But once you have this system in place, what you effectively have is a very strategic PDM, robust processes, and standardization through automation with your metrics and everything, and you're going to help drive that. Then you're doing PLM. And the nice thing about doing it this way and making sure that you're using CM2 principles or good, solid configuration management principles is this becomes very scalable for us. So as the business grows or takes on different product lines, we can scale the system to do that. We don't have to come in and start overhauling the system because we're doing everything to the core basics, right? And so as our business grows, takes on more product, takes on more volume, our processes just naturally grow with it. That's what we want you to have, is a truly scalable PLM solution. So let's talk about those 4 items real quick. The single source of truth, for example. You want to make sure that you're not duplicating data. You want to make sure that you're pushing and pulling data rather than, push or pull data still resides in one source. So we would want you to hyperlink it as much as possible. So when we're talking about single source of truth, we're talking about making sure that when information is presented, we know we can trust it. We're not going to be confused about what we're supposed to do, or not even be confused. We may just be doing something and not really doing the right thing. And that's because we don't have all the truth. And it's not, if things are being altered outside of a process and we don't have the truth, then, or we only have a piece of the truth, we don't have any truth, because we do not have what we need to make our decisions. And what that looks like within the enterprise a lot of times is you may have procurement trying to do one thing and design engineering doing another, and it feels like they're working against each other. And it's because they're working with 2 different pieces of data, or they're working with 2 different versions of their own truth. So this is to help make sure that everybody's working from the same piece of information. And so this particular situation I'm about to show you is something I had a conversation with the customer earlier this week, and this exact thing, when I showed them this, because they were describing their issue. And I said, yeah, I know what's going on, because this is exactly what was happening. And this resonated with them very well. So when we're talking about single source of truth, what that looks like, or lack of in this case, say the designer creates a CAD drawing, document, specification, whatever, and they store it in Windchill. It's processed and it's released. We're not getting into all the intricate details here, but we're just saying that this has been approved and it's in Windchill. Well, then say a quality tech, we'll use our quality friends here for a moment, and we'll say they took a copy of that. You see, they took a copy of that PDF, whatever, and they started doing some work on that. Now, right, wrong, or indifferent, and this is what happens sometimes, there's information that gets changed, overwritten, revised, whatever you want to call it. But there's data on there that they said, no, that's not what we need. That's not what we want. We're gonna go ahead and get what we know we need. And then they file it away in their Windows file system. Well, then manufacturing comes along and they say, well, we need to make this thing, this widget, and they pull from the Windchill system. That's the approved, released file, and they make it. And then quality comes in and says, well, I need to review that, check it. And they check it, and they're like, well, that's not right. They made it wrong. And so they're sitting there and they can't figure out, why do we keep making these parts wrong? This keeps happening week after week after week. Why can we not get this right? And so the big wheels get together and they start talking about it, and they're like, how are we going to stop this from happening? And inevitably what's going to come out is we need more reviews, we need more approvals, we need more processes. So what they failed to do here is a couple of things. They failed to identify the root cause of the issue, which we'll talk a little bit about root cause here in a moment, maybe. But the main thing is they didn't see that they were working from two different documents. Okay. So primary intent is another big one. And so biggest thing we see here is non-design data not being kept separate from design data. We can have lots of discussions about what constitutes design and non-design data. And then a single document representing a single design, or a single document representing a single purpose is probably a more appropriate way to say it. So the big thing here, and I know this will possibly spark quite a bit of emotion, but no tabulated or charted drawings, family tables, things like that. That's what we mean by documentation primary intent. And here's what that looks like. Well, first of all, I'll give you a quick analogy, and I'll use food. But we'll just put up a couple of examples here of different combinations of things. And you can look at the food as pieces of data. And I don't know about you guys, but these are things I would say don't necessarily belong together. Not enticing to me. If it is to you guys, then you're better eaters than I am, for sure. So what it looks like in our world is we have a drawing. Here's the geometry. And then we start putting stuff like vendor information, cost, warehouse location, shipper requirements, handling instructions, testing instructions. Every one of these I've seen on a design print at some point in my career, and none of them belong. And this definitely isn't an all-inclusive list. There could be tons of things that end up on the drawing. And when we start talking about being part-centric, even some of the design notes that you see, we would say we don't want to see the notes on the drawing. We want to see those as documents attached. But again, we'll talk about that in just a bit. As far as the family table or the charted type drawings, this is just a very simple example of what that looks like. And the reason this is such a problem is because the rule, and going back to the CM2 principles, the rule in CM2 is that if the design document for the part changes, the part changes, period. That's the end of the rule, okay? So if I change the dimension for number 80 up here for 001080, if I change this dimension, then I've changed this document. When I did that, I changed the document for 120 and 200 as well, even though I just changed 80 to 84 or whatever. I changed the document for three parts total. So the rule is all three parts revise, but that's not what we do today. And that's the reason family tables, charted drawings just don't have a place. There's other techniques, there's other ways to get the same benefit that you would get out of a charted type drawing. There's other ways to get that and keep your CM2 rules without bringing all the other problems into the mix, because you don't want to have to do that. If I'm changing 080, I just want to revise 080, as you should. So that's the reason. And that's the reason we want you to be part centric. So when we talk about being part centric, that means that all of your documents are compiled under a collector, so to speak, and that's the WT part or the enterprise part within Windchill. The bullets about prototypes don't validate design and things like that. When we're talking about the documentation, when you build a prototype, you're not proving your design. I'm sorry, you're not proving the part or the design. You're proving that the documentation is valid to provide that design. So that's what I mean when I'm saying prototypes don't validate the design. And the approved documentation changes always lead any action. So kind of going back to what we were talking about when we were talking about life cycles, when the design is approved, then it can go be procured. When it's procured, then it can be assembled, and it all flows down. So this is kind of the transformation that a lot of people are looking at when we talk about moving to a part-centric philosophy. This is where most people are, and they've got a drawing, and that represents a part, a physical part, and you've got some 3D CAD, which is pretty much governs that drawing. And then you may have a spec that is, you got the spec out here on the document, but it's in here as a note. So what'll happen is they'll come in and change the spec, but that doesn't change the note. It's still the same number. We don't typically put the rev in there. You just say, document 123. So you change the spec and nothing happened to the print. So as a result, nothing happened to the print, nothing happened to the part. Even though you change the material spec, maybe you limited the amount of carbon in it or whatever, you made some type of material change or performance change. Again, the CM2 rule is if you change the design documentation, the part changes. That's not what most people do today. If the drawing doesn't change, they don't change the part. And then you've got other information out here that kind of floats and it never gets associated. So when we go to part centric, what we're talking about is now we have this collector that associates all these things equally. So if my spec changes, my part changes. If my CAD changes, my part changes. But I also have an opportunity to start associating things like PPAP and testing and things like that doesn't change the part. So I can associate it, but not impact my part design. So now I have one-stop shop. I can come in here and look at my part and find anything I need about that part. But you may have quality is managing this documentation. Design engineering is managing all of this documentation. You may have a lab organization that's managing this, and it goes on and on. This isn't, again, an exhaustive list. This is just a simple example. And even that behavior, life cycles come into play. And the reason we put this up here is because we want people to understand that if the part is in an end state or released, then when these things change, it's a revision. If the WT part is in a maintenance state, which means it's like an in work or something like that, then all you're doing is you're iterating on that object. So we got to be careful when we talk about revising and things like that, because people think it's overly rigorous. But there are some rules that come into play if everything is set up correctly, where you get the behavior you need without without crippling the system and all the people trying to use it. This is a more expanded view of a data model. So you can see that you've got the end items with modules and assemblies and parts, and all of those have documentation and different things and attributes. So we don't want you to consume this. We just want you to see that it gets much more complex than just the simple skeleton diagram that we show you there on the previous slide. And again, when you were talking about true PLM, we're talking about design, manufacturing, and the techniques that let you get into how you can manage that. So you can have different view streams set up as well, to where, like in this particular case, this raw material is because this particular part is being made instead of purchased. Well, that's a decision being made over on this side, not over on the engineering side. And it's being governed through a material spec saying this is the appropriate material spec for the raw material that I'm going to make this part out of, that engineering has specified for us. So this is, again, where governance and automation comes into play. And then the lean closed loop process piece of this. Just real quickly on this, you've got dedicated workflows, appropriate use of workflow and approval. I want to make sure that people understand that approvals typically are misused most commonly as, if they approve it, I know they saw it. So they're using approvals for notification. That's the biggest misuse of approvals we need. Per CM2 rules, and this is one I have a little trouble with myself, any signature that, or any number of signatures over 2 that you gather in your approval process is considered wasteful. That even to me sounds a little extreme, and I don't know that a lot of people could get to that, but it is good to make you, at least it's a good rule to make you come back and say, what is the value of this person approving? What expertise, what knowledge are they ensuring is being looked at and taken care of here? And then the other big thing I would point out here is observe your corrective action activity. Corrective action meaning if I'm doing my CN process, but I'm seeing a lot of deviations, I've got something missing in my process. I've got something that's not happening. It's either in the execution side, or it's over on the implementation side or development side. I've got something that's not right, but I shouldn't be relying on deviations to correct my behavior or my product on the outside or on the downstream. And again, the closed loop. And so what that looks like, we talked about trying to use the change notice for everything, quoting, lab testing, prototyping, you name it. I see people try to throw everything into the change notice. And what we would say is break that apart and try to, say, if I would just want to do a lab test, what does that process look like? If I just want to do a quoting process, what does that look like? Take the time to do a value stream map, take the time to do a Kaizen event on it, and try to figure out where those things line up with the change notice, and couple them where you can to make them enabled at that point, so that you can run them in conjunction or concurrently with the change notice. Again, now we're talking about automation and governance, because if I try to do lab testing and I'm further down into my life cycle, well, I've tried too late now, and there's going to be problems, because if I'm in the release phase and now I'm starting to test it, well, I'm asking for information about is it valid or not. So just try to couple and layer as many different processes as we can. And when we're talking about the root cause, I told you I would talk about the root cause a bit ago. I'm using this traffic snake example for this. And if you'll focus on the red car, you'll see what's happening is the red car comes in and he breaks a rule. He crosses 2 lanes of traffic and causes everybody else to brake. And the other 2 red cars in here have to react in a different way. So everybody's having to jump and slam on the brakes and veer to other lanes and all that because somebody broke a rule. Now, what this represents is your enterprise, your team. It's not this person in this car. This is the enterprise trying to work together. So if somebody breaks a rule and it creates all this downstream holdback or backup traffic jam, what do you think the people in the back are going to say is the root cause or the purpose of this? And they're just going to say, well, the person in front of me is driving too slow. Well, just to have them to drive faster isn't the answer. We're just going to create a wreck. So we have to get to the root cause. Why did this happen? And what do we do to prevent it from happening again? So in this case, in order to govern and absolutely ensure that this type thing didn't happen is, and I know this isn't going to happen in the real world, but we would put barriers down every lane so that people couldn't do that. You can't cross 2 lanes at a time and cause people to have to do that. There'd be dedicated places where you could cross lanes where you needed. And that would, and I'm not going to say that would fix traffic jams, but in this particular case, what we're saying is, how do we stop people from breaking the rules? We want to automate it. We want to put the system in control, create a standard so that it's done in a more automatic way. And then closed loop is very, very simple. We'll just use some of the windshield nomenclature here, and this comes out of CM2 as well. But a problem report, once it's created and approved, could create a CR. And once the CR is created and approved, we can create a CN. And what that looks like is once the CN is resolved, you roll back and you close the CR and the problem report that kicked it off. That's the very simple way of showing what closed loop is really all about. Again, I don't start a CN without a CR. If this is the way, there are some companies that may choose to do it that way, but by the book, I don't start a CN without a CR, and I don't start a CR without a problem report. And there's some caveats to all of this, I understand. And then once it is created, there's got to be some mechanism to close it off to let me know that this is finished. So our approach is we try to develop these roadmaps saying, in order for us to get to full-blown automated PLM, what do we do? And we typically, you'll hear us talk about crawl, walk, run, sprint, fly, whatever. But you're typically looking at some building blocks. So down here, we're typically looking at some data management, CAD global or CAD data management. Then we get into part and docs, and then we get into change management. Some of this could layer back into here. It's not a cookie cutter. It's not the same for everybody. That's the reason I've got this shown as a sample. It's not the same for everybody. It is unique to each customer, depending on where they're at in their journey, what their data looks like, what their lifecycle schema looks like, what data sets we're dealing with, things like that. And a big piece of it, and this is the piece that we try to talk a lot about, is the culture, because you are changing data, you are changing processes, and the longer the company's been in existence, the more difficult it can be to make some of these changes. People get very, very protective of their processes, of their data, and things like that. So you got, what are you willing to change? That's a big piece of it. What are you capable of changing, and what's appropriate? So what we're looking for is that sweet spot right in the middle that captures all of those. Because again, just because you can change it doesn't mean you should. You want to make sure that it's appropriate, and you definitely have to be willing. It takes a lot of discipline and things like that. And so again, we want to make sure that there's a driving force or a steering committee, some subject matter experts that really understand all of this and are driving and communicating this throughout the entire enterprise all the time. And if we come down and we've got everybody understanding those configuration management principles and understanding why they do what they do and how they provide value to us downstream, because these eliminate some of those root cause problems, then it's a lot easier for everybody to get on board and do the right thing. It is tough. People inherently don't like change, and I'm guilty of it as well. But change is necessary for something like this to happen. And with that, I'll turn it back over, I hope, to Alex, and let him provide any questions that you guys may have or may have dropped to him during the talk.
Yeah, thank you, Kevin. That was excellent. I'll just hold one moment for questions. We do hope everyone gained some value today. I just wanted to quickly mention that a recording to view this webinar will be available on demand and sent to everyone that registered. We do also want to hear any feedback you have about topics or suggestions you'd like to see from us in the future. There's going to be a brief survey that's going to be sent with the recording. And then finally, if you enjoyed today's session, I encourage you to post, share it with your colleagues, or just give us a call. Let's see if we got any questions here. Yep, like I mentioned, we will be sending a recording automatically. It should go out within an hour or two. Kevin, we do have a question if the presentation PowerPoint can be shared.
Let me check. We do share it with some, but let me.
Would that be something maybe they can just contact us directly about?
Yeah, I'll scroll back up here real quick. Sorry for all the fast changes here, guys. I'll go ahead and here's my email address for whoever that question was. Feel free to reach out directly to me, and I will validate with the appropriate people. And but that's a good question. I haven't. We do get asked for presentations from time to time, and if it's a current customer, yes, we absolutely do. For others, we kind of protect some of our IP, but some of these things is pretty. If you dig around enough, it's out there. But yeah, this is put together hopefully in a good way, and I personally don't have a problem with it, but I want to make sure that it's okay before I do that. So whoever did ask the question, please reach out directly to me, and I'll try to get an answer to you in the next day or so.
We do have a couple questions here.
Sure, go ahead.
So the first one is, with tabulated drawings, how do you relate designs that are highly similar if they aren't tabulated?
Right. Like I said, there's a couple of different techniques, and the two that we jump to pretty quickly is you can use inherit geometry inherit feature or copy geometry, things like that. Those are the two big ones, and I'm not a CAD expert. That would be a great question for Tiago. I've kind of picked his brain quite a bit, and he has said that yeah, those are the two go-tos. Because you can even turn on inheritance when you do that. Say, I want to copy this feature to this similar part. The thing where it gets tricky is the design intent that those features are always kept together or kept in sync. So for example, if it's the same part, just a different color, and you want to have a model for every different color, then it's probably pretty reasonable that feature is to be kept in sync. So you would propagate inheritance when you did that copy feature. And so it's going to behave like a family table, even though it's two separate models. It'll behave like a family table. We also have a WinCom app that allows you to build things in family tables, and then you can blow them apart, but it'll keep the connection. So you can manage them independently, but the app will keep everything in sync for you to make sure that you don't have to do things over and over again, because that's the whole point of doing family tables, is one feature, change it one time across many designs, right? So there's a couple of different approaches. It comes down to understanding the design intent to make sure that you're doing it the appropriate way.
Excellent. And then another question here. There was a slide about revising and iterating. What in this case represents a part identifier? For instance, item number, revision, or item number only?
Okay, I think I'm understanding that question. Is the revision part of the identifier? I think is that the way they're asking that?
I believe so, yes.
Yeah, okay. That's something that's a great question, because that comes up as we talk to people about how they're doing certain things. And I think they're getting away from it now, but a lot of automotive in the past has done just that. They would concatenate or add the revision of the item to the item number. So they would have item number would be 1, 2, 3, 4, and then they would concatenate A on the end of it. So it'd be 1, 2, 3, 4A, for example. And so once they made a revision, they would just go 1, 2, 3, 4B. Well, the reality is, per CM2, that's a unique identifier. And so what you've done is you've actually given that item a new item number. Your roll digit is the rev in that case. So by the book, what we would say is your item number is just your item number. That's just the identifier. And the rev represents the revision of that item number in its collective documents. I've actually got a spreadsheet. Again, if that caller, or I'm sorry, if that person wants to reach out to me directly, I would be glad to do a one-on-one about, because I got a little spreadsheet with some macros and things like that helps show that a little bit better. And I'd be glad to spend a few minutes going over that with them on a quick go-to meeting if they want to reach out to me directly.
Definitely. I mean, if there's any questions or detailed questions that any of you have, definitely feel free to reach out to Kevin directly. Like you said, he's more than happy to help. We do have another question here. Is there any advantage or disadvantage of keeping the windshield part version and the CAD version the same?
Another great question, and that same spreadsheet would really help. Let me see if I can find it real quick, and I can probably, since I've got two questions on that right back to back. What's funny is the way windshield works. There's basically what we would call a rev sync that happens between the part and the part and the WT part and the let me pull this over into view. I appreciate everybody hanging on a little bit longer, but these are some great questions. So what we're showing here, and you can see that I've even created this one in RevSync. This is what most of our customers would do, okay? And the WT part and the CAD are going to be maintained in a RevSync. And that's because the way PTC has configured these CAD objects, they are very unique. Typically, they share the same number, okay? So you would have part number 123, and you'd have drawing 123.drw and model 123.prt. Now the rule is that every object has its own unique identifier. PTC justifies that by saying they include the extension as the identifier. That's a little confusing. And so, and because of that, most people find themselves in a need to keep this in a rev sync. Because if I say I want part number 1, 2, 3, it stands to reason I'm going to get a drawing of 1, 2, 3. So we're part centric, but we are drawing driven. Even if you go to model-based definition, you're going to run into the same thing on the model. You're going to ask for part number 1, 2, 3, and they're going to ask for model 1, 2, 3. So technically, what you would see is that, or what you should see is that the part is a number, the drawing is a number, CAD is a number. The reality is that most customers, most people find themselves in a need to keep these in rev sync. And what happens, just so you guys can see this real quick, when I was talking about the governance piece of it, when I revise my performance spec, and it's just telling me that other objects are going to have to revise for this, you'll see that all of these items went to D and in work as well, even though I just did that one. And so when I come back, and now I'm going to be part centric now, and I approve that part based on that performance change. And when I do, everything releases. So that's a great question, and hopefully that helped answer that for you.
No, that's great. It does look like that's it. Again, if any of you do have any questions after the session or want more details explained, Kevin is definitely our resident pro on this topic. I'm sure he's happy to help you. So I just want to, again, thank you, Kevin, and thank you everyone for attending. Have a great rest of your day.
Yes, thanks everyone for attending, and thanks, Alex, for all your help.